Service updates. You've probably assumed all along that there's some way to update your services, even though we haven't been focusing on that yet. But let's talk about it, because updates has a whole lot of stuff going on under the covers. So Swarm's update functionality is centered around a rolling update pattern for your replicas, which means if you have a service with more than one replica, and hopefully you do, it's going to roll through them by default, one at a time, updating each container by replacing it with the new settings that you're putting in the update command. A lot of people will say that orchestrators prevent downtime in updates, but I'm not going to say that this prevents downtime. I'm going to say it limits downtime, because preventing downtime in any system is the job of testing. You really need to start testing how you do your updates and determining, does it impact my users? Does updating a database impact my web application? It probably does. Each application that you have a service for is going to update and impact the other things around it differently. That's not the job of an orchestrator. An orchestrator can't determine that this one's a database protocol and this one is a REST application protocol that's easy. So those are going to be different complicated things that you need to deal with. So in the case of service updates, if it's just a REST API or a web front end that's not doing anything fancy like WebSockets or long polling, if it's something very simple like that or a static website, you will probably have an easy update and it won't be a problem. But other services like databases or persistent storage or anything that requires a persistent connection, those are always going to be a challenge no matter what you're trying to update. So test early and test often. Now, like I said before, this will definitely replace containers in most updates. Unless you're updating a label or some other metadata with the service, it's going to roll through and change out each container with a totally new one. So just be prepared for that. And it has many options. In fact, the last I counted, there was at least 77 options for the update command. But just about everything you want to do can be tweaked. So a lot of the options in the update command are actually create options that just have a -rm and a -add on the end of them. Because if it's an option that can be used for multiple values, so let's say a port to publish or an environment variable, those you can use many of them, right? So you need to be able to tell the update command which ones you're adding and which ones you're removing. We'll see those in a minute. This also includes rollback and health check options. So you should look at the options for those and see if their default values aren't ideal for your application and test different settings to see if it makes an update easier for you and your system. You also will see that we have scale and rollback options in here that are their own commands now. They used to be options that you had to specify with a -- rollback or -- scale, but so many people have been using those so frequently that Docker is now making them sort of first-class citizens in the command line, and they might be adding more of those in the future. And lastly, before we get to some examples, if you're doing stacks, a stack deploy to the same stack is an update. In fact, there is no separate option for stack updates. You just do a stack deploy with the same file that's been edited. Then it will work with the service commands and the networks and every other thing it does. It'll work with them to make sure if any changes are necessary that they get applied. So let's look at some quick examples and then we'll get to the command line. This one is probably the most common example that you'll be using, which is to change the image of a service. Every time you update your app and you build a new image, you're going to have to do a service update command with the image name and then the service name. And so in this case, maybe I had my application with a tag of 1.2.0, and in this case, I'm now applying a 1.2.1 image, and the service will determine, yes, that's a different image than I have running in my service, and we'll go and update them. On this next one, we're showing how you can do multiple things at once inside a single update command. You can add an environment variable with the env-add, and then you can remove a port with the publish-rm. We could also be adding and removing environment variables and publish ports in the same update command as much as we want. And on this last one, this is showing how we can use these new scale and rollback commands on multiple services at the same time, which is one of the advantages of using them over the update command is that they can apply to multiple services. So in this case, I'm actually going to be changing the number of replicas of the web and the API services at the same time. And like I said a while ago, in the Swarm updates, you don't have a different deploy command. It's just the same Docker stack deploy with the file that you've edited, and its job is to work with all of the other parts of the API to determine if there's any changes needed, and then roll those out with the service update. All right, let's start by actually creating a service so that we can manipulate it with some update commands. Docker service create -p 8088 80 name web, and we'll use Nginx, and we're going to specify a version like we always should in production. It's nice now that we actually have, in the last half of 2017, the detach option with our service create and update commands. We can actually see this happen synchronously in real time. So this will be good for our update commands to see how updates actually roll out via the command line. All right, and now if we do a Docker service ls, we see that our service is running and that it's got 1 of 1 replicas, so it's good to go. So now let's scale our service up so we can have some more replicas to work with. Docker service scale web equals 5. And you just saw that one of those was already running and the other 4 had to start. And it went by pretty quickly on mine because I already had the image downloaded, but yours may take a few minutes while they're in pending state as the image downloads on the other nodes. All right, now let's do a rolling update by changing the image of that Nginx. You'll see here that I've picked an older image. Now, Docker doesn't care about what the image actually is. It could be a completely different application for all it cares. It just knows that in this service, I'm changing it to a different image. And remember, by default, it's going to go through here one at a time. It will first remove it, create a new one, and then when that one's good to go and it looks healthy, it'll start on the next one. In the next example, we're going to change the published port, but you can't change a port. You actually have to add and remove them at the same time. So in this case, because we first published it with an 8088, we need to do a Docker service update, publish rm 8088, and I don't need to specify the value, I just need to specify the key. And then we're going to publish the new one, 9090, and then the value, which in this case is 80. You'll see that it'll do the same update process as before. Now the last example I want to talk about is kind of a tip, because you'll often have a challenge with something called rebalancing, where if you change the number of nodes or if you move a lot of things around, if you have a lot of containers in your swarm, you may find that they're not really evened out. You've got maybe some nodes that are pretty light on how many containers are running and other ones that have a lot. If you have a lot of things changing, Swarm will not move things around to keep everything balanced in terms of the number of resources used. But what you can do is you can force an update of a service even without changing anything in that service. Then it will reissue tasks, and in that case, it will pick the least used nodes, which is a form of rebalancing. So a lot of times in a smaller swarm, when I move something big or I add a bunch of nodes, I suddenly have a bunch of empty servers doing nothing, and I need to get work on them. And so what I'll do is take 1 or 2 of my services, and I will do a Docker service update -- force. And in this case, it's going to roll through and completely replace the tasks. Of course, it will use the schedule's default of looking for nodes with the least number of containers and the least number of resources used. And so that's kind of a trick to get around an uneven amount of work on your nodes. And remember to clean up by removing the service that we created in this lecture. The Docker health check command. It was a new feature added in 1.12, which came out mid-2016, the same time that Swarm Kit and Swarm Mode were available in Docker. And it was added really as a part of that toolkit, but it still works in all the different files, like the Docker file, the compose file, the Docker run command uses it, the stack files support it, the service update and service create command support it. It's everywhere. I highly recommend that when you're going production, you do engage in testing options for this health check command. It's going to work right out of the box with an exec. It's going to execute that command inside the container, just like if you were running your own exec command. So it's not running it from outside the container. It's just running it inside, which means that even simple workers that don't have exposed ports, you can run a simple command in them to validate whether they're returning good data or whatever. It's a simple execution of a command, which means it gets a simple return. It expects a 0 or a 1. So in Linux and Windows, you have exit codes from commands, and a 0 is a good thing. It means everything was fine. Anything other than a 0 is going to be an error in most applications, but in Docker, we need that application to exit a 1 specifically. So we'll show in a minute how you do that. There's only 3 states to a health check in Docker, and it starts out with starting. Starting is the first 30 seconds by default where it hasn't run a health check command yet. Then it's going to run one, and if that returns a 0, it'll start with the healthy. It'll change to the healthy option. It'll take that command and it'll run it every 30 seconds by default again. If it ever receives an unhealthy return, like an exit 1, then it marks it as an unhealthy container. Now we have options for controlling all of this, including retries. We'll see that in a minute. So this is a much better option than we've had in the past because Docker until now was just making sure the application was still running. It didn't have any insight into whether that application was doing what it was supposed to, and now we can do that inside the Docker container itself. But this isn't a replacement for your third-party monitoring solution. This isn't going to give you graphs or status over time or any sort of third-party tooling that you would expect out of a monitoring solution. This is about Docker understanding if the container itself has a basic level of healthy. So in a Nginx, it might return a localhost of the root index file. A return of 200 or 300 is fine and gives it an exit code of 0, and it considers it healthy. That's not a super advanced monitoring tool. But if it did return a 404 or a 500 error, it would then consider it unhealthy, and we can do something about that. So where are we going to see this Docker health check in the GUI? Well, the first place is in container ls. We'll just see it as this new option. It's in the middle. We'll see in a second, where it'll show us one of the 3 states if the health check is running. And that's how we actually know that there's a health check. That's the easiest way, at least, to know. And we'll see the history, the last 5 of that health check show up in the inspect for that container. And we can see some basic trend over time there. But the Docker run command does not take action on an unhealthy container. Once the health check considers a container unhealthy, Docker run's just going to indicate that in the ls command and in the inspect, but it's not going to take action. That's where we expect the swarm services to take action. So the stacks and services will actually replace that container with a new task on a new host, possibly, depending on the scheduler. And even in the update command, we see a little extra bonus by using the health checks, because the updates will consider the health check as a part of the readiness for that container before it goes and changes the next one. So if a container comes up but it doesn't pass its health check, then the service update won't go to the next one, or it'll take action based on the changes you give it. So let's look at a few examples before we go to the command line. This is one that we're using on Docker run, and this allows us to use an existing image that doesn't have a health check in it, and we're adding the health check in at runtime. And in this case, we're using the Elasticsearch image. And you can see the command is a curl localhost 9200, which is the port that the Elasticsearch is running on inside the container, not the publish port, but inside the container. For Elasticsearch, there's an actual health URL, so we can use that here. You'll notice the 2 pipes with the false at the end of that command. And that's going to be pretty common if you're using something like curl or another tool that will send out an error code that's other than 1. Remember when I mentioned that a while ago? We need it to exit with 1 if there's a problem, because that's the one error code that Docker is going to do something about. So we need to make sure that, in this case, a shell will always return the false 1 exit code if there's anything coming out of that command other than 0. So it's a nice way to get around that problem. And it just so happens with curl will give other potential error codes, and we don't want it to do that. In the actual Dockerfiles, we can add the same command. The format's a little bit different, But you see that we have these options here. We have the interval, the timeout, the start period, which is new, and retries. So the interval is what you would think it is. It's by default every 30 seconds, how often it's going to run this health check. The timeout is how long it's going to wait before it errors out and returns a bad code if maybe the app is slow. The start period is a new feature that allows us now in 1709 and newer to give a longer wait period than the first 30 seconds of the duration. Before, it would always just wait the interval time before it started the health check. But maybe you have a Java app or a database or something that takes a lot longer to start. Maybe it takes 5 minutes. So you can add that start period in there. It'll still do health checks. But what it'll do is it won't alarm on an unhealthy check until that time is elapsed. So if you set 2 minutes in there, even though it's health checking every 30 seconds, it's going to only consider it unhealthy once it's past that 2-minute mark. The last one there, retries, means that we will try this health check X number of times before we consider it unhealthy. And that gives maybe a potentially unstable app a chance to come back with a healthy and recover on its own before we consider this a truly unhealthy container. The basic health check command you would use in a Docker file is called health check, all capital letters there. And the same format exists where if we're just doing a simple curl of the local host because maybe it's a PHP app or something, we can do that. And this is how you would add all those options in to a Docker file. So you would see how I add the timeout interval and the retries before the command itself. The first one there for the basic command, notice I don't have to put in a CMD if I'm just giving it the command to run. But if I want to show options, if I want to give it custom options out of the box with the timeout and so on, then I have to specify which one is the command. Now, these aren't two different lines. Notice the backslash on the end of the first line there. So don't get that confused. And here we have a simple example of what it might be like if you had a static application running inside an Nginx server. You could set the interval and the timeout from your Docker file, and you would just have it simply do a curl command on the local host. And if it returns a 200 or a 300, it considers that fine. If it returns a 4 or 5 or something else, it considers that an error. Now you notice here that I have an exit 1, which is the same thing as a false. I did that just to show you that certain examples on the internet will have a false, certain examples will have an exit 1. They both do the same thing. Here's a little bit more advanced example. In this case, we're using a PHP app that's combined with Nginx. And what I've done is in the resources, you'll find a link to this PHP example. I've added in a custom Nginx config file that uses Nginx and PHP FPM status URLs. So both of those applications have their own status page and sort of a health check ping URL. And you can use those in your apps if you're using PHP or Nginx. They're two different URLs, but you can use both of them inside the same health check. In this case, we're using just one of them, and we're throwing in the localhost /ping, which is actually a PHP FPM status command, but you have to enable that inside your PHP FPM. Again, in the resources of this lecture, there's a link to a PHP Docker good defaults. You can go check that out on GitHub where I've shown this example a little bit more detailed. Next, we have a Postgres example. So in the Docker file, I can use a different URL. So here we have a Postgres application where in the health check command, I'm using a command of PG is ready. Now, with different apps, there's different tools. With Postgres, it comes with a built-in tool that's a very simple testing of a connection to a Postgres server. So it doesn't validate that you have good data or that your database is mounted properly. It's simply going to say, does this database server allow connections? Yes or no. So that's a neat one that you can do out of the box. And here's what it would look like in a composer stack file. Very similar. You'll notice that the start period down there requires a different version. So since the health check command came out in 1.12, it was actually supported in 2.1 of this compose file. But if you're going to use the start period, that means you have to update your compose file to version 3.4 in order to support that, because the start period came out over a year later after the health check command did. So let's start out with some simple run commands. What we're going to do here is we're going to start a Postgres database server without the health check, because by default it doesn't come with one. And then we're going to run it again with a manual health check command that we'll add at the command line, and we'll see the difference. So here we're just going to call the first one P1. We'll run it detached from the official Postgres image. And if I do a Docker container ls, you'll see that there's nothing indicating a health check here. But if we do that same command again, and call it p2 this time, we're going to add a health command. And this time we're going to use the pg is ready, which we talked about earlier, to test that the connections are available on this Postgres server. And we're going to tell it that the user we need is the Postgres user. We don't actually need to give it a password. It's not going to try to log in. It's just going to try to validate. And we'll use the Postgres image. And now if we do a Docker container ls, and I zoom out a little bit, you'll see that it says up 4 seconds, health is starting. So now we get this additional feature in our status of our ls command. And it'll stay in this starting state for the default 30 seconds until it runs the health check command for the first time. And now that we've waited over 30 seconds, you'll see that it's changed to status of healthy. Now, if we do a Docker container inspect on that P2, we'll see at the very top of that we have this new health status option. And in this case, I've only been able to run it twice. And you can see the output there that it's showing it's accepting connections. All right, now let's do some service create commands with that same database and that same test health check. What we'll see here when we do this is that there's 3 different states that a service goes through on starting up. It's preparing, which usually means it's downloading the image. It's starting, which means it's executing the container and bringing it up. And then it's running. And without the health check command, the starting and running are very quick. They're almost instantaneous. And we'll see that here with a Docker service create, name p1 Postgres. And once it's done preparing by downloading the image, you'll see that it goes immediately from starting to running because there is no health check. It doesn't have anything else to do other than start the container and say, yep, the binary is running. But if we do that same command, Docker service create, and call it p2 like before, and give it that same health command, and we start this service with the health check command built in, what we'll see is that it'll go from preparing to starting, and it will sit at the starting state for the default 30 seconds until the first health check runs. And this is now the Docker service expecting a healthy state before it considers this service fully running. After the 30 seconds is over, it'll shift to the running state, and then we get the last little verify there just to make sure that it's considered stable, and then we're done. So you can already see out of the box that with services as well as service updates, we're going to get this extra bonus of health concept if we use these commands whenever we can.